Hello, everybody. Welcome back. This is, I realize I haven't uploaded in a bit, so this is gonna be, I'm gonna upload get to at least halfway through the unit in this upload stretch. First of all, so if you're listening to this on, a couple of days after I uploaded it, happy Easter. Hopefully you've enjoyed your, Easter weekend in the safety and comfort of your home, and done everything that you could, have fun while still following all social distancing rules, etc., etc. So yeah, we're gonna get started on integer exponents. This is gonna be the lesson 4.1, and again, hopefully this is mostly stuff that we've kind of seen before. The key here is, again, this is review of exponent laws from the last lesson, exponent law. Really, the integer, as the title suggests, the integer exponents only adds the fact that there could be negative integers present. And we'll see how, like, the division exponent law is really just the multiplication exponent law in a different way. So, a brief preamble. So basically, the idea here is whenever we have a negative exponent, we know that the base doesn't belong where it is. That's what we mean when we say negative exponent. For example, if we had 2 to the power of negative 2, what that really means is because this exponent is negative, you see here that all things stated equal, this 2 is now, this base here is in the numerator of our fraction. Now, you might say, okay, I don't really have a fraction, but we know that 2 is just this divided by 1. We can make anything into a fraction if we really wanted to, right? We just throw in a divide by 1. Invisible ones are everywhere. So the idea here is that because this 2, number 2, has a negative exponent, we understand that 2 is not really supposed to be in the numerator. I mean, it could be in the numerator, but the better way to write it is in the denominator with the positive exponent. And because there's nothing in the numerator now, it just becomes a 1 in the numerator. Again, invisible ones everywhere, right? This is a 1 times 2, and since we moved the 2, what's left is just the 1, right? And so the idea here is we have to get used to the idea is kind of like, I say flip the base or take the reciprocal of the base. It's really when you make the exponent changes from positive to negative or vice versa, negative to positive, we're going to take what the base that's in the numerator and we're going to flip it to the denominator, or vice versa, right? For example, if there's a negative exponent, this base here is in the denominator. We are going to convert that base to the numerator and make the exponent positive. We're going to change the sign of the exponent, and by moving the base from the numerator to the denominator or the denominator to the numerator. And of course, this can be written even if we have 1 times 2 to the 2, right? I'm going to move this base to the numerator, and I'm going to change the sign of the exponent. So that's really what we're doing here. We're moving the base from numerator to denominator, and we're changing the sign of the exponent from like positive to negative or negative to positive, where we're going. If it's just one number, it's easy because there's invisible ones. If it's a fraction with a negative exponent, it kind of works. Okay, I'll explain this the long way and hopefully it makes sense. So let's say I have 2 divided by 3 to the power of negative 2, for example. One way you can think about it is, this is why flipping the fraction might seem easier. So I just flip the fraction, make this 3 over 2, and now this becomes to the power of positive 2. I changed the sign of the base. But really what we're doing here, if you want to think about it in one more step, is this negative 2 applies to both the 2 and the 3, right? Because it's in the bracket. So this is 2 to the power of negative 2 divided by 3 to the power of negative 2. And then what we're doing is, okay, we're taking this base here, this part of our fraction. This here means the 2 is in the numerator with a negative exponent. So I'm going to put the 2 in the denominator and make the exponent positive. This part over here, the base is in the denominator with a negative exponent. I'm going to move the base to the numerator and make that exponent positive. And then what I do is essentially I group the square out kind of, and make this 3 over 2 the whole squared, because it's 3 squared over 2 squared. This is just the backwards of our first initial step. And that's kind of what we're doing. This is essentially a simplification. However, it does get confusing when you're dealing with like ones. That's why I recommend not memorizing this rule, but really understanding where we're getting this rule from. We're essentially just using the principle that we move the base from the numerator to the denominator, and that changes the sign of the exponent. Even just a regular 5, right? This is in the numerator because there's nothing else there. I can move this 5 to the denominator and change the exponent. Here there was a 5, this is a power of 1, again, invisible ones. I'm going to make that to the power -1. And 5, this is equal to 5, basically. 5 equals 1 over 5 to the power of -1. And so hopefully we can see that this is what's happening. This can also be written actually as 1 over 5 bracket -1, because we know 1 to the power of anything is just 1, whether it be positive or negative. For example, if we were to apply this rule over here, we get 5 over 1 to the power of 1, and we know 5 over 1 is just 5, which eventually leads us back to this. So hopefully we see that I've just gone a full circle, used the rule back twice. So again, different ways of representing. The idea here is not to get confused between all these different things, and just keep in mind the fact that, okay, realistically, what am I doing? I'm moving the base from the numerator to the denominator and then changing the sign of the exponent. So as long as we're okay with that, we can do pretty much anything, any of these questions. So I'm just going to check how long this is. Oh, it's not long. This is super easy. Okay, we're going to try some of these questions. This is fairly easy. So first I'm going to use the first law. So 2 to the power 4 plus 7 is 2 to the power 11, divided by 3 times 2 is 6. 11 minus 6. Oh, I was going to talk about how the division law is just So if you really think about this, this is 2 to the power 11 times 1 over 2 to the power of 6, right? I've just split the numerator part and the denominator part. And instead of, I could just use the division rule here, like this rule, when you divide the same base. But instead, I am going to use over here, if you look at this 2 here, this is 2, that's in the denominator, so I'm going to change that 2 to the numerator, and I'm going to flip the sign of the exponent, make that a -6. And this is, again, just a multiplication rule where I'm doing 2, 11 plus -6, and we'll see that's 11 minus 6. So really, what I'm doing, the division rule is just a combination of these two rules, and we'll see that. And okay, hopefully you see that. In terms of why you have to see that, I wouldn't say there's any particular reason. You could use the division rule, of course, to get here 2 to the power of 5, which is in fact 32. But it's useful to see these things, just to get practice with using the negative exponents and such. Obviously, not all the questions are going to be this easy. Here you have to do some inventive trickery. Well, that makes it sound like weird. Essentially, what you're doing is, instead of this 4, right, we're going to make these the same base. So now we have a base of 2 and we have a base of 4. And obviously, we can't combine things which have different bases. So we have to make the bases the same. And the only way to do that is to transform. Always start working with the higher power, so a higher base. So we see 4, so we're going to actually write 4 as 2 squared. And that still has a -2 power. So this was 4 to the power of -2. What we're writing is, again, still just 4, which is this, to the power of -2. Instead of 4, I'm just writing 2 squared, because I know 4 is 2 squared. Again, it's very important to be able to be familiar with these things enough to say that, okay, 9 is 3 squared, 27 is 3 cubed, 32 is 2 to the power of 5, 64 is 2 to the power of 6, or 4 to the power of 3, or 8 to the power of 2. And depending on what base you need, you might have to be familiar with these important numbers. What are those important numbers? Just anything in the power of 2. So like 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. If you ever played the game 2048, you're familiar with these numbers. And if you aren't familiar with these numbers, I'd recommend playing the game 2048 so that you can become familiar with these numbers. And then we have, of course, the 3, 9, 27, 81, 243, 729. You don't really need to know more than that. 4, 16, 64, 5, 25, 125. Hopefully we're okay with that. 625, 3125. Stuff like that. 16025. And then the 6, 36, 216. That's all you need to know. 749, 864. You don't need to know any more than that. 981, 729. You get the idea. Okay, after that long, just me blurting out numbers, we're going to continue working on this. 2 to the power of 3 divided by, I'm using multiplication rule. 2 times negative 2 is negative 4. And here, again, I can use the division rule or like combine both rules. I'm just going to use the division rule here, negative of negative 4. Again, if brief times 1 over 2 to the power of negative 4, this thing here, the base is 2 in the denominator. So I'm going to convert that. I mean, this was here, and then this actually becomes in the numerator, and I'm going to flip the sign. So it's actually 3 plus 4, which is what the same thing as I get here. So again, 2 to the power of 7 is 32, 64, 128. That's the answer. And hopefully we're seeing how to do this. We're going to make the base the same. So instead of 9, I'm going to know that's 3 squared. So I'm going to write 3 squared. 3 to the power of 12 divided by 3 to the power of 8. 3 to the power of 4, which is 81. Very important to see what the question is saying. Simplify where possible and then evaluate. So, I mean, could you have just put 9 to the power of 6 in your calculator, got some big number, 3 to the power of 8 in your calculator, got some big number, divided the two numbers, and got 81? You could have, but that will only give you like half mark on a long answer question. Because most of the marks in the work here is going to come from the simplification part, which is you using the exponent laws to simplify to this. This will give you like half mark here or 1 mark there, 1 mark, probably 1 mark for this, and then 1 mark for your final answer. So like that's kind of this is probably worth only like 1 mark in total. So like, or 2 marks in total. So probably it's just like this and the final answer, but or probably this. I don't know how the marking scheme works, but essentially like you have to show the simplification is what I'm getting to. Okay, let's take a look at this. 3 and 2 are bases that cannot really be combined in any way, so we're just going to have to evaluate this because there's no simplification to be done. However, we can't, I mean, you could put 2 to the power of negative 4 in your calculator, but simplification actually includes making all the powers positive. So that's part of the simplification. So again, you can't just put 2 to the power of negative 4 in your calculator and get a value. What we have to do is think of this as, okay, you don't even actually have to split up the fraction. Essentially, again, there's different ways to do this. In the notes, you might see that it's just simplified. 2 to the power of 4 is written as 1 over 16, and we've done the simplification after that, which is fine. But we're going to, try and practice some negative exponents. So we're actually going to take a look at this. And we'll see here that 3 to the power of positive 1, so I'm going to leave that there in the numerator. This 2 here has a negative exponent, and it's currently in the denominator. So I'm going to move it to the numerator, and I'm going to change that exponent. I'm going to change its sign. So from a negative, it's going to become positive. There's nothing else in the denominator. This 2 was the only thing that was in the denominator, and I have moved that to the numerator. So there's just a 1 there. So this is 3 times 16, which is 48. That's my final answer. 3, 5, and 2 are all bases that cannot be combined. So again, what I'm going to do here is I'm going to, again, look at this fraction here. I have stuff in the numerator, and this is what's in the denominator. Let's see, 3 to the power of negative 2. That is the 3 here now being in the numerator with a negative exponent. So in this fraction, I'm going to move that 3 to the denominator and change that exponent to positive. This 5 to the power of negative 2, it already has a positive power. I'm going to leave it up there. 2 to the power of negative 5. It's in the denominator with the negative exponent. I'm going to move that base to the numerator. So obviously when I move it, it becomes multiplied by that thing. And I'm going to change the exponent to a positive. So this is like me simplifying using the exponent rules. And again, if I try and evaluate this, I get 25 times 32 divided by 9, which is 800 divided by 9. But it's also important to remember or look at the other way. So if you look at, I guess, the solutions that are posted online, it's been done another way. And this is kind of using this formula very literally. So we have 3 to the power of negative 2. So I take the reciprocal of 3, 1 over 3, and make that a positive power. I have 2 to the power of negative 5. I take reciprocal of 2 and make it a positive power. This is like kind of another way to think about this. I don't like this method. It leads to too many fractions and it just gets... I mean, you could do this. Like 1 squared is just 1 divided by 9 times 5 squared divided by... Here you get 1 over 2 to the power of 5 and then rearrange stuff and eventually you'll get the same answer. You could do it either way. And I guess I will talk about the other way a little bit more when we get to... I'll do it both ways to show you, but realistically either one works. Especially in things like these, you're going to have to know how to do it. Not really, either way works. So here we have 2 to the power of negative 3. So if we look at the way that we started this lesson out, 2 is now currently in the numerator, because of course this is just there's no denominator, it's just 1. So we're going to move 2 to the denominator and we're going to change the power to a positive. So that's 1 over 2 to the power of 3. This is where, like, I guess moving numerator denominator might get a little bit confusing. You have to be very careful here. You know, you kind of have to know to put a 1 in the numerator because there's nothing else in the numerator after you've moved the 2. So there's an invisible 1 there. And you kind of have to know that. But other than that, still, this is 3 and then 4 to the power of negative 1. This is just 4 to the power of negative 1. 4 is in the numerator here. I'm going to move 4 to the denominator and change the power to a positive 1. So that's just that. This is 1 over 8 plus 3 over 4 times 2, which gives me 6 plus 1 is 7 over 8. Again, if you wanted to do it the other way, we're going to take reciprocal of the fraction and change the sign of the power. So 2 to the power of negative 3. Reciprocal of 2 is 1 over 2. Oh, okay, hopefully we're good with the idea of reciprocals. Reciprocals just you flip the fraction. So if this is 2, this was actually like 2 over 1. And in this case, you make it 1 over 2 to the power of now positive 3. You can write it like this, sure. Plus 3 and then 4. The reciprocal of 4 is 1 over 4 to the power of positive 1. And this is 1 over 8 plus 3 over 4. And we're back to here. So they'll give you the same answer. So hopefully we're okay. You can do it whichever way you'd like. And again, the important thing is you know how to work with these instead of worrying about realistically which way you're doing it at this point. So again, I will say again that it is very important to note, I guess I should mention, that the numerator denominator kind of thinking does have some caveats. So for example, I can't do it with this question because there's adding signs in the middle. The numerator denominator only works when everything's a multiplication. It doesn't work when there's addition signs because you can't just move the 4 to the denominator because it's not one term. It's not being multiplied. It's, how do I put this? It is tied down basically because of this other term. This is a binomial, and so you can't just take one part of the binomial and switch it because it is a binomial term in the numerator. So here what we have to do is, again, do it the reciprocal method. So we take 4 to the power of negative 1. We're going to make that 1 over 4 to the power of positive 1 plus 3 squared divided by 1 over 2, reciprocal of 2 to the power of 3 plus reciprocal of 3 is 1 over 3 to the power of positive 1. So hopefully we'll see here, whenever I see a negative exponent, I just take the reciprocal of the base and then change the exponent to positive. So after this is just a lot of simplification. So I need to times this by 4, times this by 4 to make a common denominator at the top. This is 1 cubed over 2 cubed is 8, 1 over 3, so I need to multiply this by 8, and this by 3. So here I get 37 over 4 divided by, actually I'm going to write divided by, what is this, 11 over 24? And you'll see here how I've converted this big divided by to an actual divided by sign. So because I know exactly where things go now, times 24 over 11. This is just division of fractions, right? You flip the second fraction. And I'm going to do some cross canceling. 37 times 6 is 42. 222 divided by 11. And that's my answer. I don't think that's... I don't think you can do anything else to that. So that's going to be that. Let's take a look at H. There's a couple of ways, again, you can do this. I'm going to do it the easiest way first. And realize that, okay, normally the first thing I would do is kind of simplify inside the bracket. So normally what I would do is I'd say, okay, there's no adding weird addition signs like option G or question G, so I can just start flipping stuff, numerator to denominator. Here I have 2 to the power negative 3, so I'm going to move that 2 to the denominator, make it positive 3. Here I have 3 power negative 2, move the 3 to numerator, make it positive 2. So this is still to the power of negative 2, and then I have to, apply the negative 2 to both. So this is 3 to the power of negative 4 divided by 2 to the power of negative 6. And then I have to flip things again, because now I still have negative powers after I have multiplied the negative 2. So move the 3 to the denominator, make it positive. Move the 2 to the numerator, make the power positive. And this just gives me 2 to the power of 6 is 64 divided by 81, I think, yeah. Alternatively, the easy method is to realize that instead of working to simplify this first, if I just multiply it here, so again, because there's the whole bracket, this negative 2 applies to both here and here. So realistically, what this is 2 to the power of negative 3 to the power of negative 2 divided by 3 to the power of negative 2 to the power of negative. This negative 2 applies as an exponent to both the numerator and the denominator. So this is just 2 to the power of 6 multiplication rule, 3 to the power of 4 multiplication rule, and this just gives me 64 over 81. This was the smart way to do it. So hopefully we saw that and we approached it like so. Question number I is, again, fairly straightforward. I see I have a 4, so that's what I'm gonna deal with. Take the reciprocal, make it a positive power, minus, take the reciprocal of 2, make it a positive power, plus 3 to the power of 0, and hopefully we're okay with something to the power of 0 being 1. I'm going to move it doesn't really matter because the negative is still included with the square, so the negative is eventually going to just disappear and become 1 over 16 positive, minus 1 over 2 times 8 plus 1 times 16 over 1 times 16, which is basically 1 minus 8 plus 16, which is 9. Sigh, give me a second. We're back, 9 over 16. Okay, so we're going to take a quick look at that homework, see if there's any complicated questions. Page... where was I? 222. I think it's this textbook, yeah. Let's see, where's 222? 4 to 9, 13, 15. So actually, let's see, 4, this should be fairly easy stuff. Again, yeah, fairly straightforward. Like even this one looks a bit complicated, but the base is negative 8, so I'm just going to take negative 8. Multiplication law, anything to the power of 0 is 1. And the negative goes away because it's an even exponent, 0 being an even number. Rational form. I don't think there's anything too complicated here. Again, if we're looking to simplify something like this, for example, or even e, for example, I would do 2 to the power of 8 times, I'd move this actually no, I wouldn't do that. I would just use division rule here. Minus 6, 2 to the power of 8 times 2 to the power of negative 11, 2 to the power of negative 3. And after I get that negative, I'm going to make that, take the reciprocal, make the power positive. This is 1 over 8. Likewise here, 13 to the power of negative 5. I have a fraction and there's a negative power. So again, I'm just going to flip the fraction and make the power positive. So as you can see here, it's use. So like whichever method you like, it's useful to look at things in all the different methods using all the different rules that we talked about. Simply because there's some situations where some methods are going to be just easier to use. So like you shouldn't have to first multiply the negative into both of these things and then flip both of them just to get this answer. You should be looking at it as like, okay, I have a fraction to the power of negative. I can flip the fraction and make it positive. Instead of using like the moving to the numerator denominator kind of idea. And now this is just 13 negative 5 plus 8 minus 2, which is actually 13 to the power of 1, which is 13. Let's see, anything, let's see, again, this is 1 over 16 minus 1 over 4. This is 5 plus positive 4, I think, because you'll make this first 2 to the power of, or negative 2 to the power of 2, because you flip the fraction and you change the sign of the power, and that is just positive 4. So there you go, that's that. Why is there 1,000 here? So 5 to the power of negative 3 is 1 over 125, or 1 over 5 to the power of 3. This is 1 over 10 to the power of 3, which is 1 over 1,000. This is 8 times 1 over 1,000, so 8 over 1,000. And then you times this by 8 times 8. The common denominator is 1,000. Again, here is where flipping the fraction comes in handy. So again, you're just going to flip the fraction, make the power positive, flip the fraction, make the power positive. This is just 2 over 2, which is 1 for question C. So again, hopefully you're trying all the rest of these. I don't think they're particularly difficult. 4 to 9 we had. In rational form. Again, this is just flipping the fraction. Just be careful whether the negative is inside or outside the bracket. If it's outside the bracket like C, D, or F, all you're going to do is you're just going to calculate this and then just throw a negative sign in front of it. So 5 to the power of negative 3 is 1 over 5 to the power of 3, which is 1 over 125, and you just throw the negative on, negative 1 over 125. Let's take a look at this. 5 to the power of negative 2 is 1 over 5 to the power of 2, which is 1 over 25, but there's a negative sign, so you just throw on the negative sign. Same way, this is negative 1 over 36, etc. And when the negative is inside, you kind of include that in your bracket, and then you just see whether it's even or odd. So if it's odd, the negative stays. If it's even, the negative kind of multiplies into itself and goes away. Things like that. Okay. I'd actually take a look at some of these questions. These are very good questions to try and to practice. Let's look at that one. So here again, you can do this many different ways. Let's try and simplify inside the bracket first. So this is xy to the power of n divided by x to the power of 2n, y to the power of 2n, because I expanded this. And all this is still to the power of 2n, of course. And then I'm going to try and move stuff around. X to the power of 1 minus 2n, y to the power of n minus 2n, which is actually just negative n. And this gives me here x to the power of 2n times 1 minus 2n, y to the power of negative 2n squared. And I'm supposed to evaluate this for n equals negative 1, x equals negative 2, y equals x equals negative 2, y equals 3. So we'll get to the x and y later. I'm just going to simplify this for n equals negative 1. 2 times negative 1 is negative 2. Y to the power of negative 2 times negative 1 squared. Let's see. 1 times negative 2, this is positive 3. So now that becomes 2 times negative 1 is negative 2. So x to the power of negative 6, y to the power of negative 2, which is a negative 2 to the power of negative 6 times 3 to the power of 2, which is actually 1 over 2, negative 1 over 2 to the power of positive 6 times 3 squared. This is negative 1 over 64 times 9, which is negative 9 over 64. Should be your answer. And again, it doesn't say simplify first, so technically you could put the values in here, but it's good practice to learn simplification with not numbers, right, with variables as well. Get used to doing those kinds of things, like here x to the 2n, y to the negative 2n, x to the negative n is just x to the n, y to the negative 2n, and you can put these values in, etc. I really wanted to focus actually on, what is it, 13 and 15? Okay, we'll evaluate using laws of exponents. Let's look at this stuff. This stuff looks interesting. Again, this should be easy. Just take the reciprocal here. And be careful when you're doing it, because this is like 8 times 1 over 16 divided by 2 to the power of 2, so you can actually change that to times 1 over 4, because you get divided by 4, right? And that's just times 1 over 4, and you can get 1 over 8 here as your answer if you do some cross cancellation. This is just 6 to the power of negative 1, which is 1 over 6. Again, here the best bet would be to do this first, which is just 9 over 4. This is 1 over 4 times 16 plus 1, which is 17, which is 17 over 4. Here, because everything is multiplication, again, we can kind of do some simplification without getting involved with too many fractions. 2 to the power of 5 divided by 3 to the power of negative 2. I have 2 to the power of 5. I'm going to move this 3 to the numerator, make it positive. Here I'm going to move this 3 to the denominator, make the power positive. So realistically, in the numerator I have 2 to the power of 5, denominator 2 to the power of 4, so that's just 2 to the power of 5 minus 4, 3 to the power of 2 minus 1, so that's 6. This is just 1 plus 25 is 26 to the power of negative 1, which is 1 over 26. Again, here everything is just multiplication, as you can see, so I can just use a quotient rule because they're nicely set here like this. Negative 2 minus 1 is plus 1. Minus 2 is plus 2, which is just 3 to the power of negative 1 times 2 to the power of negative 1, which is really just, 1 over 3 times 2, which is 1 over 6, whichever way you want to think about that. Here we have some positive signs, so it's not easy for me to, I can't use quotient rule, that's A. And part B is I can't use my, just move things from the numerator to denominator, because that's essentially what I'm doing is quotient rule, or they're interchangeable. When I can't use quotient rule, I can't really use that flipping thing, so I have to do, 1 over 16 plus 1 over 3 divided by 1 over 9 plus 1 over 8. And just simplify this accordingly, like times 16, this is a pain, times 3 times 3 times 16, which is like 19 over 48 divided by, 17 over 72, I think. And then I'm going to write this as 19 over 48 divided by 17 over 72, because I can change that easily to 19 over 48 times 72 over 17. I think this cross cancels by 12, actually by 24 maybe even. Yeah. 19 times 3 is 57 divided by 34 should be my final answer. And this is also a very similar method. Again, you can't really use the division rule because there's a negative and a positive here, which kind of make this a binomial, which means you can't use the rule. So you have to, make these individual fractions 1 over 5, 1 over 4, 1 over 5, 1 over 4, and do some calculations there. Question 15, explain the difference. Okay, this is a good question because it is something I was hoping to get to. Explain the difference between evaluating negative 10 to the power of 3. In this case, the negative is part of the base, right? So your answer will have a negative in it most probably. Here you see negative 10 to the power of 3 is just, negative 10. Negative 10 to the power of 3 is really just negative 10 times negative 10 times negative 10, which is a negative 1000. Again, if this was an even power, the negative would have gone. But the idea here is there's no kind of fraction that's going around, or there's no numerator denominator switching. Here, 10 to the power negative 3, the negative is in the exponent, which makes this a fundamentally different question than this question right here. If the negative is in the exponent, what I do is I flip the fraction, or now it's in the numerator, I move it to the denominator, and then I make the power positive. So you can see that this is 1 over 1000, which is very different than negative 1000, right? And it's important to not get confused between these two. Be careful to properly look for whether the negative is in the exponent, in which case you have to flip the base, or switch the base somehow in terms of numerator denominator, or if the negative is in the base, which means you just treat that as like a regular base and you continue doing your work. Again, this is something we've talked about. Hopefully you're familiar with. Negative 10 to the power of 4 is negative 10 times negative 10 times negative 10 times negative 10, which is positive 10,000. Because there's 4 negatives, they multiply into each other and give you a positive. Here, negative 10 to the power of 4. The negative is not included in the bracket. To the power of 4, the exponent 4 does not apply to the negative. In this case, it does apply to the negative. So because it doesn't apply, you just take 10 to the power of 4, which is 10,000, and there's a negative sign in front of that number. So this is your answer here. So it's important just to be careful with that. And also, I'd like you to try some of these ones. It's very important that we be able to go backwards. So we have to know that this is just 16 to the power of negative 1, right? Because there's a positive 1 here. We're going to move the 16 from the denominator to the numerator and change that exponent to a negative. So here x equals negative 1. The same way we're going to work here is 1 over 100, which is just 1 over 10 to the power of 2, which is 10 to the power of negative 2. So x equals negative 2. Here x equals 0. That's straightforward because 1 is 2 to the power of 0. 0.25, 1 over 4, 1 over 2 squared, 2 to the power of negative 2. Again, 2 is in the denominator. I'm going to move the 2 to the numerator and change the sign of the exponent to make it negative. Right? And so n equals negative 2. Hopefully we're okay with the last step I'm doing. If 2 to the power of n equals 2 to the power of negative 2, that means n has to equal negative 2 kind of deal. So you can try these ones. This is 1 over 25 squared, 1 over 12 squared. So n equals negative 2, n equals negative 2 here as well. So yeah, again, these are some good extension questions. Give these a try. And as always, if you have any questions, post them on the forum or leave a comment below this video, however you'd like to get in touch with either me or Mr. Tremoli to clarify your doubts. And that will be it for this lesson. We'll be continuing with this unit, of course, and I will talk to you next time. Peace out.